And then here's your bread and butter questions worth 2 marks. I think in an exam they're worth a bit more than that, maybe 3 or higher. But draw dot and cross diagram for magnesium oxide. Now that gives it away there. The fact that it's not Mg2 or MgO2 is going to be a 1-to-1. Okay, magnesium is in group 2, oxygen is in group 6. Magnesium is going to give away 2, oxygen is going to receive 2. So it's just a nice little, they're happy together like that. So I've drawn this as magnesium's got a full outer shell because he's given his 2 electrons already. So you can imagine imagine another electron shell above that originally, and he's got maybe 2 electrons, he's just given them away, and now he's got a full set, but he's an ion, he's a positive 2 ion. Now oxygen is happy, she got 8 electrons, but she's got a charge of negative 2 because she's picked up 2 electrons, and that's 2 marks. And the name of that type of bonding is obviously ionic because you got a metal and a non-metal. Magnesium atom and oxide, the magnesium atom in the oxide is replaced with the calcium. So this is going to be calcium now. Does the bonding get stronger or weaker? Well, as you go down that group, the bond is going to get weaker. They're going to get more reactive. If you know the alkali metals, the trend, they get more reactive as they go down. That's because they give away their electrons easier because they've got a bigger radius. If you imagine now, if you look at this magnesium and it becomes calcium, you've got another circle. In fact, I might draw that in another color. Let's go for red. Let's go for blue, actually. So calcium is going to have another one with maybe, I mean, that is a magnesium, but you can imagine another shell on there now with 2 electrons. It's further away from the nucleus, so the nucleus is going to be positive. These things are negative, so the further away from that nucleus, the easier they get rid of their electrons. I should say discharge there, but the answer then is weaker because calcium has a big ionic radius, so more willing to lose electrons, less attraction to the nucleus. 3 marks. We're on 9 minutes. Hopefully I can wrap this up in 12 minutes now. So water, H2O, is a compound essential to life. Name the type of bonding within a H2O molecule. Well, it's going to be covalent. It's going to be that sort of Venn diagram shape. So you're going to have 1, 2, 3. These are hydrogens. Sorry, and that's an oxygen, and the hydrogen is going to bring 1 to the party, and oxygen is going to get 1 each because oxygen is in group 6 electrons, it needs 2. So I've said, yeah, covalent, they share electrons, electrostatic force between positive nucleus and negative electrons. That's what keeps this together. And then it's on about intermolecular forces here. So why is the value for H2O much higher? So this H2O, you can see its boiling point is 100. We know that anyway. But the boiling points for the others are quite low, so they all exist as liquids, sorry. Would it be liquids? Yeah, minus 185, yeah. Of course they would. Because no. HCl. Minus 85. Boiling point. They would have boiled already. Okay. That's confused me a bit. I'm not a chemist, but I thought HCl was an acid, hydrochloric acid. Yeah, I'd have to check on that. 85, that's definitely a gas at room temperature there. Anyway, hydrogen bonding between. So back to the question. Explain why the value for H2O is much higher than the others. It's higher because it's got a stronger force that's needed to break those bonds. It's because it's hydrogen bonding. Hydrogen bonding exists between the top row of, so you've got hydrogen, you've got nitrogen, fluorine, and oxygen. So, sorry, I'm just thinking, I haven't got a periodic table on me at the moment, but I think it goes nitrogen, oxygen, then fluorine. Fluorine and hydrogen are the strongest bond because fluorine has got, it's going to have 9 off the top of my head. So yeah, oxygen's 8. So fluorine's going to have 9 protons in its nucleus. Therefore, hydrogen is got 1. So competing for that electron is, you know, if I draw this. So there's your hydrogen, and there's your fluorine. Your fluorine's got a really big nucleus compared to hydrogen. It's got 9 protons in there, so it's going to hog these electrons. The electrons are going to be around fluorine most of the time. Okay, that's called a permanent dipole attraction, whereby fluorine gets the electrons the majority of the time. So that is the strongest sort of bond that can be made there. But hydrogen bonding, it could be nitrogen and oxygen, and then any others like so chlorine. It's still, you know, even though it's hydrogen, chlorine is sort of one period below these, so there's an extra electron shell sort of, so you got these inner electrons there sort of blocking, shielding those other electrons. So that's why, hopefully I'm confused you. I confused myself by you, because I was surprised to see HCl is -85 there. Maybe I'm just having a bit of a moment, and when I look at this again it'll be fine, but we're over the 30-minute mark now anyway, so this is going to have to be 2 videos. Alright, so it said hydrogen bonding between hydrogen and oxygen, strong forces need to break bonds. Okay, 2 marks there. Probably spent a bit too long on that one. Which is a shame here, because I've only got 1 page left. So water reacts with lithium to produce lithium hydroxide and hydrogen gas. So we're going to see some sort of volume, we're going to see moles, we need a concentration. Okay, so I'm going to use moles over concentration times volume, or you could say molarity. So I've said here, because I want to know the concentration, my concentration is moles over volume. So moles over volume. So my moles is easy, is 0.15, but my volume, because it's 250 centimeter cubed, and we need to be in decimeter cubed. So decimeter cubed, just like a liter really, so that you can divide by 1,000. So if I've got 250 there, it's going to be 0.25, which gives me 0.6 moles. That's only worth a mark, which is naughty really, so you're going to have to be spot on. Usually they give you a carry-on mark, even if you get this wrong, but you've got to be spot on here for 1 mark. And then describe the bonding in lithium. Well, lithium is a metal, so it's going to be anything relating to metallic bonding, isn't it? So a regular arrangement of protons, delocalized electrons. I know I'm a bit of I was doing this with a class and spelt delocalized wrong. And then electrostatic attraction between ions and electrons. So there's the word delocalized there. And that's 3 marks. So an easy 3 marks there for remembering that. And then that's only worth 1 mark. Doesn't really make sense, but there we are. Okay, so that's that paper. I hope you enjoyed that as much as I did.